Will a $400 welder work for your needs? We'll find out. ArcCaptain reached out to us and said, hey, if we send you our MIG200 welder, will you tell all your viewers what you think of it? Give your honest opinion? We said, that's all we do. Send it on. So they did. We have the ArcCaptain MIG200 here. Got a lot of great features here. This is an inverter welder up to 200 amps. But let's go ahead, dive in, take a look at these features. Then we'll use it and come back and talk about pricing a little more and what we thought of it. This is the ArcCaptain MIG200 inverter welder. This is a synergic welder, which in short means it has some automation built into it to help with definitely newer welders or new welders in the trade, or even novice welders. It's definitely a help, especially when you're looking at the MIG process. This will run on 110 volts or 220 volts. Now the MIG200 stands for 200 amps of output. Now that is really limited based on your voltage. So if you want that max 200 amps of output, you do have to run at 220 volts and you have to be running a larger wire like 1mm or 045 wire as well. So there are some limitations based on wire size and based on voltage. You can run the smaller spools on this, obviously. You can also put on the spool adapter there and run the larger 10, 11 pound spools as well, but those smaller 2 pounds will go in here. If you're doing a lot of welding, definitely recommend you buy those larger spools. They're going to last you longer and be more efficient on cost. Now setting all this up and setting up your tension and running your wire, that's very easy to do. We will do that here in a moment. We'll install our rollers as well in here, our roller in there as well, and we'll install the correct roller. But let's go over some more of the features of this welder. Now the welder comes with the typical 110 volt plug. It also comes with this adapter here for your 220 outlet and obviously the adapter, so you just plug that into your plug on the welder and then plug this into your 220 voltage, and now you've bumped up the voltage to 220. So it comes with that adapter. You don't need it. So out of the box you can run it on your standard 110 volt outlet and then bump that up if you want to be going to higher voltages. I would recommend you go to a higher voltage, especially if you're going to be welding anything 1/8 inch and above. I highly recommend you going to a 220 volt plug. Now we also get a MIG torch with the kit, kind of a Euro style connector, so love to see that. And then some different tip accessories as well, so let's go over those. So we get a couple of 030 tips, as well as I believe those are 040 or 045 tips as well. So you get a couple of different options with the gun and a couple of other shields and tips as well. Even a little tool for using with those, but I would recommend just using some MIG pliers. And then we get some rollers. Now to be honest, I'm not sure how many come with the MIG200. I don't believe all of these were with the kit, but I do know several of them were. But I just wanted to cover some different rollers that we have sitting here in front of us. Over here on the left are the 0.6 rollers, which would be for your like 0.25 wire. And these are the 0.8 rollers or 0.8 millimeters, which would be for your 030 wire. And these are the 1 millimeter here. There should be also a 0.9, which would be your 035. And this would be for your larger 045 wire as well with a 1 millimeter. So you can cross over on some of these as well. But in addition, like this 0.8 here, that's actually a knurled groove. This is a V groove, or a U groove, I'm sorry, that's a U groove. And then this is a V groove roller, so exactly what it says it is. It has a V groove in it. And actually, if you flip this over, it says 0.6 on the other side. So usually you actually get a 0.6 on the left and a 0.8 on the other. And the same with this one, 0.8 on one side, 0.6 on the other. And then the K in this one means knurling. So again, another knurling. So 0.8 on one side and 0.6 on the other. And again, that's going to be your 0.25, your 0.30 wire, and your 0.35 and larger wire over here. Now we're going to be doing some mild steel with some mixed gas. We'll go over that here in a moment. And so we're going to want to use this 0.8 V-groove roller, and that's what we'll install in just a moment. Now, a couple of more things that will be included with the kit. Your stick lead, so nice tensioned stick lead here. So good quality stick lead. Also love the larger DINS connector, and we'll go over the details in that in just one moment. And here's our grounding lead, or our earth ground lead, and again, large DINS connector there. And we even get our gas line for hooking to our gas cylinder that will then hook to the welder. Now here's where we're going to connect all of our leads, and here's that Euro style connector for the MIG torch. Love to see that. So our wire is going to come through here on this larger hole, and then this is where the gas is going to come through, and all the communication and signal to the MIG torch is going to come through this one connector here. So there's not different things you have to hook up. Basically, you screw this in and lock it in, and you're good to go. And we see basically the work lead coming out of the unit. So this is basically connecting to the MIG torch here. And so we either, based on the type of shielding we're using, based on the type of welding process we're doing, is going to determine which lead we connect to here. On the left here is the positive, and on the right here is the negative. Now I will go ahead and kind of jump ahead and say, if we're going to be doing a DC electrode positive, meaning we're going to be welding steel, we're going to be using an argon CO2 gas or a mixed gas, as well as a non-flux wire, we're going to go DC electrode positive, which means this is going to go over here and lock in, and then our earth ground or our earth clamp is going to go over here on the negative side. So DC electrode positive, our electrode, our work lead is actually going to go positive, and that means that's going over here. We'll go over that in a manual in just one moment, but I did want to point out when I mentioned about the DINS connector, and these are just basically easy connectors. Most welders are using them now, and it's just easy to push in, turn it a half a turn, and you're locked into place. And one thing about this is on a lot of welders, you'll see these being 3/8 or like 0350, something like that. But if you look, these are 50 DINS connectors, or 1/2 inch. So love the larger size. That means we're just going to get a better ground, a better work lead, better connection across the board. So I love to see that in both of these are 050. And then this port here is basically another communication port, and usually used for like a spool gun or maybe even a TIG torch. Basically you've got a signal going through here where you can call it on and off. And again, that'll be used for any accessories. So you can use a spool gun with this. We don't have it included with it, but you can use a spool gun, which would be great for like doing aluminum welding with an inverter welder like this. Here on the back of the welder, we have a fan, which this is going to aid in keeping that inverter cool, as well as all the electronics cool as well. Also on the rear of the welder is the gas input. So this is where we'll connect our gas line going to our argon CO2 tank, as well as the main power on and off button. Now I thought, rather than just kind of chit-chatting for any longer, let's go ahead and start this thing up, maybe even work our way through the manual very quickly, skipping over a lot of the stuff, and just get this welder set up and started welding as fast as possible, but really kind of walking you through what your process may look like if you purchase this welder. Now we're not going to walk all the way through this welder user manual, so don't worry about that, but there are some key things that I wanted to point out, and I'm kind of impressed because a lot of these inverter welders don't have great manuals, but this one actually does a very good job at having a lot of this. Like right here, technical parameters right out of the gate. You welders like to know this, and you new welders, these are things that are pretty important things. So in other words, how much current, how much voltage, amperage is your machine going to put out? And here, right here is a table showing you, and you see at AC 110 volts, so 110 volt outlet. In the MIG process, you're going to get up to 160 amps, so 30 to 160 amps. But at 220 volts, you're going to get 30 to 200 amps in the MIG process, and the TIG 20 to 200. Now, I will tell you, I haven't been able to achieve 200. We have been able to achieve 180, But again, we'll get to those details here in a moment. And then you can even look here in overall efficiency. It is an inverter welder, so it is changing from AC to DC. So you're gonna lose some efficiency in that process. So it tells you right there at 85% efficiency. And it also tells you duty cycle at 60% at 110 volts and 60% at 220 volts as well. Other things, it kind of walks you through each of the buttons, what they control. It even explains the whole schematic system or the electrical system. So I like to see that. Rarely do I ever see that. And here's the socket I was showing you a few moments ago when I was talking about the spool gun, and it tells you which leads are actually used. And again, more explanation of things about the knobs and the buttons and the controls. We're not going to go over all that. Here's something else pretty important I like to see. So right here, this FeCO2, this Fe mix, basically this is asking what type of welding are you going to be doing, and then it's, you know, what type of wire type, and it's telling you what drive roller do you need, what your polarity needs to be, what your gas type. So we're running a 20% or 25% CO2 to argon, so 2575 CO2 argon, and so our polarity needs to be DCEP, which means DC electrode positive. We need to run a V-groove pulley, and our wire type is ER70S6. I'll show you that here in a moment, and we're going to be welding steel. Obviously, we can't weld aluminum with that. We shouldn't be welding stainless steel with that, even though arguably you can. Regardless, this is the setup we need. This is what we're going to be doing. And then it even goes into operation mode of actually kind of explaining the whole process during welding. There's some real light schematics that you probably can't see in the picture here that again gives some more parameters. Explains a lot of setup here, and then MIG mode, MMA mode, which would be your stick, TIG. So basically with this welder, we can do stick welding, we can do MIG welding, we can do MIG spool welding, we can also do TIG welding as well. And again, explaining the process. Now, one thing I like here is this is welding parameters, but for stick welding, and it's talking about electrode diameter and recommended current. It does not give us a table like this for MIG. I wish that it did, but it does not. But anyway, and then we get into the MIG process, and it talks about the Euro connector. So anyway, just a great manual here that explains a lot of stuff, basic knowledge of welding, and it even gets into push-pull and what you ought to be doing with stick, what you should be doing with MIG, even in explaining MIG, MAG, CO2 welding, FCAW, and how so much of that falls under GMAW as well. So again, kudos to them for having a manual that has a lot of information. So if you take the time to read this, you'll probably learn a lot. Again, this is explaining your typical travel process and degree of the head. You shouldn't be having it straight up and down. You should have an angle to it. And then even talking about forehand welding or backhand welding. So basically pushing the MIG versus pulling the MIG. There's plenty of discussion about that. If you ever want to find that out, just look on the internet. So again, don't want to touch on every single thing. I do wish that they had a table in here for MIG. That would be great, but they're easy to find. Go out there and look. We may even have a link in the description. And, oh, wow, look at there. So highly recommend. Go somewhere, put a sticker on your welder, but if you're new to welding and you're not sure, then just kind of write down some common, you know, like a small table for yourself. Okay, I'm going to weld some 1/8 inch, some 3/16, some 1/4 inch. Or you may have, you know, 18 gauge, 20 gauge, 16 gauge, and write down the amperage and the voltage of where, you know, commonly that is used. And we may link you to a table as well, but use your manual, write things in it so you have it for a quick kind of a hot list, if you will. Now let's set up this welder and get to welding. Okay, the first thing we want to do, we want to make sure that our welder is off and unplugged, and we're going to open up this side here. Now we need to install our spool of wire, but we also need to install our drive roller. So there's a thumb screw right here. Easily take that off. And as I mentioned, we want to install our 0.8 V-groove pulley. Now you need to look on this pulley because I've seen welders again that use either the inside or the outside. Now we know the 0.8 is larger, so it's over here, and actually this is utilizing the groove on the inside, and you can see where the wire will line up with that, so that's no mistake there. So basically the 0.8 needs to go to the inside. And now we can just take our thumb screw and put it back on. You can kind of cinch that down. It doesn't have to be super tight, but you can cinch it down pretty well. Now we don't close this up until we actually get the wire in there. So then that will go down and this will go up, but we'll leave that up for right now. Now you could actually go ahead and install your wire and have it poking out a little bit, but I'll go ahead and install the MIG torch and then we'll install the wire. But basically you can see this is not hard to do, and it would be very hard to mess up, really. You see where the big lead's going to stick in, and then basically this big nut is going to turn and lock it into place. So those Euro connectors just make it really easy, and then get that started to thread and lock that down. And so now you're ready to rock and roll. Let's install the wire. So this is for our larger spools. We'll move that out of the way. We're going to install a smaller spool, and this is ER70S6, so mild steel, and it's 030 wire or 0.8 millimeter. Now in this case, on this welder, we want this wire facing down, so coming down off the roller. So make sure your wire doesn't come all unspooled, so you want to keep some tension on it, and you want to take this washer here, and you want the lip sticking out, because then that spring is going to go around that lip, and then this nut, the lip to the inside, and then make sure you don't cross thread it. That is a plastic nut. And then basically you want enough tension on it so it doesn't just start freewheeling. You don't need tons of tension on it, but just a little bit. Then you're going to take your wire here and you're going to feed it, and it's got to go into this tube over here as well, so it's not tough to do. Just get it lined up. And now once you get it in a few inches, then make sure this is down. Pull this roller down so you can see that roller is actually putting tension on that wire, and this is going to flip up. Now there's spring tension on this here, and you can apply more pressure by screwing this down. You can see there's kind of a counter there, 1, 2, 3, 4, 5. And again, as long as there's some tension on there, you really shouldn't need a lot of tension to push that wire through the lead. Now there's a couple of things we can do here. We can still kind of push this along if we wanted to, or we'd have to take the tension off to do that, but I could still push that. And I like to do that to make sure that I'm past where it actually enters into the torch lead, and that I'm not hanging up on something there. So now I know I'm past that, and again, I can put the tension back on it, and then I can use the welder to actually feed it to the torch. Okay, now we want to make sure that we get the right tip in, so we want to find the tip that coincides with the wire we're running, and that looks like 1.0 and 040. So that's not the tip we want, and that looks like an 030. Now you can look at the holes in these and actually tell the difference in which one's larger and which one's smaller, and we definitely want the 030 for the wire we're running. So that just threads in very simply, and you can hand tight that. That doesn't need to be really tight. Some may argue with that, and then we can put our shield on, and that locks into place. That does not thread on. However, you can twist it because of that spring right there. It will kind of lock into place, but you can thread it on, and then if you try to loosen it, it's kind of that spring kind of locks it in there. So if you twist it, it will come off, but twist it counterclockwise, and then that locks it on. Okay, now we want to take our gas line and actually install that and make sure it's not leaking. I'd recommend you using some type of soap or something to confirm you're not leaking after you have it turned on. Usually it's 11/16. Just give that a little tighten. Should be like a compression fitting, so it shouldn't need to be really tight, but now we know it's in there. And again, let's hook it to our bottle and make sure we don't have a leak here. You do not need Teflon tape on this. This is not the type of connector you need Teflon tape, so do not put Teflon tape or any type of dope on there. It should seal on its own. Okay, as we mentioned, we're going to run this in 220, so I'm going to put on my adapter, and I'm going to go ahead and plug this in. And now we're ready to turn it on. And now we'll power the welder up. So you see, as it powers up, our screen comes on, and we'll go over some of the different parameters on the screen here. You may also hear the fan running, again, keeping all the electronics cool. Now it's kicked back off, so as we're using that, it will be called on and off as it senses it needs to be cooled. Now we could, sit here all day and explain every single thing in here, but I don't think we need to do that. Now, depending on what you're wanting to do, the triangle button or like the play button here, this will actually bounce between, the S is not showing up right now due to the other parameters, but basically you can bounce between M is for parameter group storage, and then your voltage parameter and spot welding time. So you could actually have spot welding time in there, but we're going to leave that here on voltage. And then where it says model, it's really not supposed to say model. It should say mode. And I'm not sure if that's mode exclamation point or if it says model, but I'm pretty sure it says model, but just understand that is your mode. So if I push the mode button here, you'll see it changes. There's MMA or stick, there's TIG, there's MIG spool gun, and then there's MIG. That's what we're going to be doing is MIG. And then this little round button here, that's our wire size. And there's our 0.6. We're doing 0.8 or 030 wire. If we jump over here to syn or a synergic, it will bounce between, basically synergic is off, so we have a little rectangle here. I'll push that again, synergic is on, and when it's off, you can see we can basically decide how much wire feed speed or what the wire feed is manually. That's where we can dial that in manually, and that would be with our amperage. But when synergic is on, and now we see the SYN here in this little box, and this is basically set to amps, that's set to volts, and as we change our amperage in the synergic mode, the voltage is automatically going to change with that amperage. So that's what synergic mode does. It kind of changes everything as you change your amperage, or even if you change your wire size, things like that. Your voltage parameter and amperage parameters will change based off of wire size. And then if we go down to here, this is basically 2-touch or 4-touch welding. Now, 2-touch is typically what people do, and that means you hold the power button or hold the trigger button on and it's welding. You let go of it and it stops welding, versus you can click it on and then click it off if you want to do it that way. So you click it on, it stays welding, and then you click it off and it stops welding, and that's called 4-touch. But we just want 2-touch, so that's right there. And then when we go down to this one here, this is going to change the shielding gas of, are we running complete CO2 or 100% CO2? Are we running a mix, which that's what we are, or even into flux core welding where the actual flux is in the wire and you're not using shielding gas, or even into some other ones as well. But we are using a CO2 mix, and so that's what we're going to set up right there. So we see we're on MIG, we're at 16 volts and 100 amps. We're in synergic mode. Highly recommend you to leave it there. We're in 0.09. Nope, we want to be 0.8, which is our 030 wire. And now we're set up and ready to weld. And again, the cool thing is all we have to do is mess with our amperage here to say, okay, we're going to be welding 1/8 inch, so somewhere around 130 amps, and you see it automatically puts our voltage here at 18.2. Now here's the cool thing. I know when I'm typically welding 1/8 inch steel, I usually like to be maybe somewhere close to 19 volts. Well, if I want to be at 19 volts, then what I can do, I can trim this voltage. So when I'm in synergic mode, the voltage doesn't necessarily control the voltage where you can actually tell it how much you want. It has a trim of +3 to -3. So in other words, if I always like it a little hotter, I can say, well, set that parameter to 0.7 more. So now that's changed to 19 volts. Did you see what I did there? If I change that back to 0, now it's the trim set at 0. That's at 18.3 volts. But again, if I say, well, I usually like that closer to 19 volts when I'm at 130 amps, I could trim that to 0.7, and it's going to add 0.7. If I had -0.7, it would take away 0.7. So that's kind of your trimming of the voltage. So if you're not exactly happy with where synergic is setting you based off of how you're welding, you can trim that. And many times you may trim that based on whether you're going vertical, up and down, sideways, inside, outside, things like that. you may set those trim levels to be a little different. So it's pretty cool. We don't have to change all the parameters. We can just change the trimming of the voltage and how hot or how cold we want that weld. Now let's go ahead and set this. We are going to weld some 1/8 inch first. So let's set that at 130. I'm just going to say, now let's leave it at 130, but let's trim that up. I'm going to say give it 0.5 more. So almost 19 volts at 130 amps with 0.8 wire, and again, mixed shielding gas. We're in synergic mode, 2-touch and MIG. We never did install our earth ground, so here we go. Again, 1/2 inch dense connector or 0.5 dense connector. So there we go, we're locked in there. Okay, we're just gonna weld some simple overlapping 1/8 inch here. So what I'm gonna do, I'm just gonna ground this and go ahead and tack it to my table and then leave the ground on the table. And if I do this correctly, it'll be easy to remove. Now, first thing, to get my lead out of my torch, I'm gonna go ahead and remove this here, and I'm gonna go ahead and remove the tip as well. I'm going to remove my ground so I don't accidentally touch the table. And then I can, once I hold this button down, it should go into inching mode where it actually does a fast spool to run that wire out, because we haven't run the wire out to actually the tip yet. There it is. So now we've got our lead out, and I like to take the tip out just so, again, it's not a potential problem of it actually getting stuck in the tip and not coming out, because sometimes you can create a bird's nest inside your welder there where it's trying to push that wire out. In fact, I like to actually look in the welder while it's feeding that to make sure that it's not getting all bunched up, but you can also hear it. So again, let me ground this here, and I'm just going to first cut my wire off with just a little stick out. Tack here. And tack here. So now I should be able to just put my ground lead over here, and we should have a good enough ground there. Again, I'm just going to tack the corner here. Tack the corner here. And now let's see how we do. Not bad. A little rusty, but not too bad. I'm going to bump my voltage up just a touch. Actually, I bumped the amperage up to 133 and 19 volts. That looks more like it to me. I like to run a little faster, so a little more heat in there, a little more wire feed speed, and that looks like a decent weld to me. Again, I need more practice, but that's laying down a very nice weld to be our second weld out of the gate. Now we'll do some more welding here in a second, but let me recommend a couple of things here, a couple of simple tools. Buy you a set of MIG pliers. I think those are like, I don't know, 15, 20 bucks on Amazon, and these are, you know, Irwin MIG pliers. They've been around for a long time. I'm sure there's different companies that make those MIG pliers, but they're just great. They work great on your tips. You can cut wire, you can grab all sorts of things, clean out the tips with the ends here. So just a really good set of pliers, and highly recommend you have a good set of MIG pliers. Also recommend you get a torch tip cleaner as well. So this is a torch tip cleaner, and so it's got all sorts of different sizes for cleaning out tips, and it's even got a little file in there as well where you can file the end of the tip also. So highly recommend, and you'll find tons of uses outside of welding for those welding tip cleaners, like paint guns and things like that. And then also a thickness gauge. So this will tell you what gauge of steel. Don't know if you can see this here, but it says 24 gauge, 22 gauge, all the way down to 1/4 inch or 14 gauge 1/8 inch, 10 gauge, and 3/16 quarter inch. Now let's get another fresh set of, we can call them coupons if you want to, but basically it's just scrap steel. So we're just having some fun here, welding some scrap. And by the way, if you don't have any scrap, you could probably find a company that has plenty of just scrap laying around that you can weld on, grab some scrap metal, or you can buy a 3 or 4 foot stick of this from your Lowe's or Home Depot or home improvement store for probably 10 or 12 bucks, and just cut it up into 4-inch pieces, 3-inch pieces, and just weld them together. Continue to weld down them, stand them up vertical, all that sort of stuff. Very easy to do so. Play with your amperage, your voltage, your wire feed speed, and how it looks when you get done, how you like it, uphill, downhill, all that stuff. This is where you practice. And again, the reason I'm tacking this to my table is so that I can put my ground clamp over here and it not be in the way of me welding. Just easier to do so. I could probably clamp it over here and just lay this on the table and it'd be fine, but that's gonna ensure that I've got a good ground by tacking it to the table, and now I'm clamped to the table. And also I've got my steel cleaned as well. You can see it sanded off. There's no mill scale. That's gonna help me to make sure I've got a good ground on it as well. And then go ahead and tack the corners. So again, you're not dealing with a ground issue and making sure you're getting polarity to your piece. So go ahead and tack it in place and then practice your weld. Again, not bad at all. Third weld in, looks pretty good to me. I'm sitting back too far in doing this. The camera's kind of in my way, so I probably need to get up on the puddle a little more. Watching that puddle will tell you everything, whether you're stick welding, MIG welding, TIG welding, it doesn't matter. Aluminum welding, if you'll learn to watch that puddle and how you're feeding into it, that's gonna tell you everything about your weld, and you'll start to learn to see things happening before you even lift the helmet. You'll actually understand that, hey, I'm a little off. I know this weld's gonna be cold. I know it's gonna be hot, just by seeing that puddle. Now I may have moved way too fast and leaned way back off of that weld, and it just did a crummy job. So just an example of not getting up on that puddle, seeing what's going on, moving too fast. Let that puddle build and learn to just work that torch where you need it to build the heat where you need it, because if you're not building that heat and not feeding that puddle, then you're going to get void spots, you're going to get cold spots, and you're not going to get a penetrating weld. So we're going to weld some of this 3/16 here, and there is some mill scale lift on this, so it's not particularly cleaned like the other ones were. We're just going to turn up our amperage. So that's as high as we could go, is 160 amps with the 0.8 wire selected. Now we can fool the system and say, let's select 0.9 wire, and now we can take that amperage up to 180. Even though we're only running 0.8, we can tell the system, hey, we want 180 amps to weld something a little thicker, and now we've got 180 amps. And I could even continue to trim that voltage up if I needed to. Okay, now we've got a 90-degree weld we're going to do here. Not too bad. I had a kind of a slip about right here. Still didn't end too bad, but it's where my glove kind of grabbed and I couldn't slide with it. But it did kind of jump right there. Otherwise, Decent heat in that, decent penetration. I think I should have stayed in the puddle a little longer and built a little more heat into that. And now I'm really pushing the system here. I'm going to weld that piece of 1/4 inch onto that 3/16. Not bad. Looks decent. The MIG200 did a great job. Now, we were not able to get it all the way up to 200 amps. I'm sure there's some other settings and stuff to be able to get that up there, but we did get it to 180, and we're welding 3/16 and even 1/4 inch steel. Now, if you are going to be continually welding 1/4 inch plate, 1/4 inch steel, then you probably want to step up to a bigger welder anyway. But as far as welding anything, 3/16, 1/8 inch and smaller or thinner, this is a great welder and very easy to get going. Setting it up and everything out of the box, I would say within an hour you could easily be welding with just a little bit of knowledge, and continue to educate yourself in welding. This is a trade that I am not a professional welder at all. And I would highly recommend that every time you get a chance, practice your welding, because the longer that span is in between when you're welding, the more you're going to forget. That just is how it is. And then as you pick it up, you get all that stuff back, and then continue to push yourself and learning how to go uphill, downhill, different areas, even into doing TIG stick, which we didn't get into, or using a spool gun, but we're already 30 minutes in here. Don't want to waste any more time. This welder is typically $499. It's typically a $500 welder, but I'm seeing it right now at $399 or $400. We'll have a link in the description for you. Be sure to follow us on Instagram, Facebook, Twitter, and even TikTok. Hey, if you don't mind, would you hit that like and subscribe button if you haven't done so already? And by all means, if you hated our video, well, give us a thumbs down. But would you let us know in the comments why? Have a great day and keep smiling.